we're doing specifically around data quality. And before we get started, I want to give you guys just a quick overview so you have a little bit of context for the rest of the talk. So many people don't realize we've actually been around for about 20 years now. And last quarter, we hit the 100 million member mark. So we have 100 million members worldwide. And we are on track to spend $6 billion on content this year. Billion with a B. And you guys seem to really like it because you watch a lot of it. In fact, you guys watch about 125 million hours of content every single day. We are also, as of Q1 2016, in 190 countries worldwide. And last I checked, we're around 1,500 different devices that we support. So there's a reason why I'm telling you this. We have 100 million members in 190 countries on 1,500 different devices, watching 125 million hours of content a day. We have a lot of data. In fact, we are writing about 700 billion events to our streaming ingestion pipeline every single day, and this peaks at over 1 trillion events. And this is all getting processed and loaded into a 60 petabyte data warehouse, which is on S3, and is built entirely using big data open source technologies. We're writing about 300 terabytes a day to that. And this is actively used across the entire company. So from content, trying to decide how to spend that $6 billion, to our product teams trying to understand the quality of experience, to our S&A teams trying to understand the performance of experiments, we're using this data. So we're reading about 5 petabytes a day from this. So at these volumes, quality clearly matters because if you have a problem, it's really, really hard to fix it. And when you have data that's getting distributed and used across the company for a data-driven business, then when you get the stuff wrong, it can really have a big impact. As you might have heard, we are entirely in the cloud, all of our cloud platform infrastructure. And so we're using AWS behind pretty much everything you're going to see here. A quick look at how data is moving through our data pipeline, or data platform. Everything starts with a visit to the site for this diagram. So you visit the site, and we start logging. We're going to log the website tracking information. We're also going to log the content that you were presented with because your visit is completely personalized. We are also going to log what you're watching. And this is going to go into our streaming Kafka pipeline and land in S3 in a raw ingestion layer. We also have all of our operational data sitting in Cassandra, so we are ingesting this through a open source tool that we built called Agathis, and landing that in that same ingestion layer in S3. And then we are reading that data using a variety of data processing technologies, but primarily we still have a lot of PIG, and all new development is primarily written in Spark. And we write that data after we process it back to S3 into a data warehouse data bucket, and also move some subset of that over to a fast access layer so that we can consume it from a variety of data viz tools. It's also really important to us to make sure that the data is widely available to anybody who needs it. And so our data platform team has built a variety of tools, like the Big Data Portal is a web-based UI. We have notebooks, we have Pylon containers. And to facilitate this access, both from a scale perspective and then also to facilitate this cloud-based infrastructure that we have, they've built a variety of data services. So I've listed just 3 here, arguably the most important ones. So Genie, which is our federated job execution service, Metacat, which is a federated metastore, and then Kaggle, which is a collection of Python APIs. And this is an imperfect diagram because really those are embedded at pretty much every touch point, but you can just understand conceptually that they are what's facilitating this, this entire interaction with the platform. Okay, so now we get to talk about data quality. So I had some slides in here that really described the data quality problems that we're faced with, but I realized that they're not unique You guys probably have the exact same problems that we have. I think they're pretty common. And I also realized that if you chose this talk when you had so many other great talks to choose from, you probably already understand that data quality is important. If that was a false assumption, see me afterwards. I'll be happy to talk with you. But the thing is, data quality is important. It might not be your favorite thing to do, but it is important. And the more data-driven you are, the more important it becomes. The other thing, though, is that data quality is extremely difficult, right? There's no magic bullet here. And the problem is that, in the best case scenario, you create a job, you deploy it, everything's fine, you make a change, and suddenly you've got a bug. And you've got an immediate feedback loop. And you can catch those issues and you can fix them. But what happens when you have something changing upstream, right? And there's no notification to you that the volume of data has significantly increased, or that they've changed the schema, or they changed the meaning of the data in some fundamental way. And then you're discovering that usually because your data consumers are telling you. Or when you upgrade the platform and there's a change in behavior that somebody was not or nobody was expecting. Or you get really weird things that are hard to identify, like issues that only occur if it's a leap year, or if it's a full moon and Jupiter's in retrograde. I mean, things that are really, really hard to find and understand. And so you have two fundamental ways you can approach this problem. You can say, I'm going to try to identify all the things that could possibly go wrong. Or you can say, we could, but that's a lot of effort, and I'm not sure that we're going to be successful. So instead, we are going to try to identify when there's a problem and not focus so much on the why of it. And so what I want to share with you is the philosophies here that we have chosen, which is more around that latter approach. And some of the things here are going to be very specific to Netflix, but I think that from a philosophical perspective, you can apply the same thoughts, the same ideas in your own environments. I think they're pretty transferable. So the first component that makes up our data quality solution is Metacat. And Metacat is that federated metastore. It is also something that we use to extend the metadata that we collect about data objects. So this is allowing us to have one place to go to, and then we can access the data regardless of whether it's sitting on S3 or in Redshift. And then we can collect additional attributes that are very unique for us or might be common, but things that aren't facilitated by existing solutions. I think this is going to be similar to HCAT in principle. So you start with this logical table, right? This table object in Metacat, and hopefully this is not news to anybody. But what's different in this big data world with the architecture we have is that fundamentally this table object is separate from your physical data. In traditional databases and legacy data warehouses, your table was a physical representation of the data itself. Here we can separate those. And that's actually really, really cool. And it's going to give us a lot of capabilities to do things in a better and smarter way than what we might have done in the past. So we have the option to point this logical table to the physical data, and we can choose to point it to all the data at a partition level, or we could choose to only pick and choose some of that, right? So when we are making these pointers, we are also defining these partition objects inside of Metacat. And this is going to give us information around the S3 path and the data keys. It's also going to give us really rich statistics about that partition. So whenever data is written using Pig or Spark, we are collecting metrics. I call these like generic data profiles. So for each partition, it's going to tell us things like the number of rows, the number of files, the size, across the entire partition, how many nulls were present. So really useful information. So in this case, you can see here that we've got 25 nulls present in this partition across all the fields. We also have this information available at a field level. And so we can break this down further and say, here are the metrics where those nulls were present. Primary language ID had 4 nulls. Is that a problem? Looking at this, I don't know, right? I don't know if that's something that happens commonly in this table. Maybe it's late arriving data. But I know that it exists, right? I can collect this information on my metrics around min and max and summa values. I can also do it on my characters. I can say, here's my min and max string lengths. I can look at my Boolean. So there's a lot of really good information that's collected. And this is really powerful for 3 reasons. The first one is we can share these statistics with things like Spark and the cost-based optimizer so that it can make better decisions and our jobs are going to be more efficient. We can also share this with the users when they're trying to understand either the behaviors of tables they own or they're trying to query a really large table and they don't understand the behaviors. It's a lot faster to say, are there nulls in the table by looking at the stats than it is to query it for many of the tables we're working with. And then the third thing is that we can use this for quality checks. We can say, well, there should be no nulls in the entire table. So I saw 25 and here's a problem. I can have nulls in the table, but I should never have them in this primary language ID. So I've got a problem. Or I can also do things to indirectly, so that's more of like a direct thing. I can say, this is a behavior and I'm expecting it. I can also indirectly capture things that might be harder. So a common occurrence might be for you to get somebody in the business telling you this KPI looks off. There's value there, it's not zero, but it looks lower than what it's been in the past. So we can look at the sum of these metrics and look for changes over time and say, you know what, we've noticed a huge dip in the sum of this field. So that's more of an indirect way to be able to determine that there's a problem with the KPI. And it's letting us get to it faster and more efficiently. But this itself is not putting together any of those rules, right? This is just exposing the stats. And then I mentioned that we can extend this with additional data catalog information. So some of the ones that are most relevant for data quality would be primary keys, which is, again, this is a logical construct. It's not physically prevented from writing the data to disk, but we can at least check to say, okay, here's the primary key. Were there duplicates in there? And what is the expected behavior? So we have that capability. The column types, is this a metric or an attribute? And then we can understand the behaviors accordingly. The life cycle, so where's this table in its life cycle? At the beginning, we would have a brand new table and we would consider that sunrise. And we probably don't need the same kind of quality checks on that. Or maybe in your environment, you need a lot more because things are more likely to go wrong on the sunrise table. Who knows? But we at least understand that this is a brand new table. Is this something that's on its way to being deprecated, right? We call those sunset tables. Is it a transient table? Probably don't really need to measure quality on those in the same way. And then you have like the core, which when you factor all that stuff in, it starts to get smaller and smaller. We have a core that's the actively loaded ones that we consider to be our production tables. And then we look at another level, which is the audience. And so this is a hierarchy for understanding what is the consumers look like for this table. Is it used by a single person or by a team, like a single team? This is probably like a low impact team, right? Or table rather. So then we have more of like a medium impact would be something that's being used widely across many teams or across an entire org. And then you get to your really high impact tables, the ones that are being used broadly across the company. So if something goes wrong there, it's going to propagate everywhere, and it's going to be a big mess to fix. And so audiences, it's imperfect, but it's a fairly good proxy for measuring impact and understanding what is an appropriate level of quality coverage for a table. And then valid through timestamp is something that is just telling people, okay, we have evaluated the quality in this table, and we're making it available for you to use up through the certain point. We're also sending it to downstream systems to say that the table's ready to, or the upstream table's ready and their downstream processes can kick off. Okay, so that's Metacat. Metacat was not actually created specifically for data quality. It serves a lot of other functions. Quinto is actually built entirely for data quality. It is our data quality service. And so this is where we start to define the metrics and the expected behaviors and what we should do when they fall outside of our expectations. So the first concept here is a metric or a template. And this might look familiar to many of you if you've written generic query solutions. But basically, it's just a parameterized query. And we've defined a primary key in here, which remember we know from Metacat. We have our table, we have a partition, and we're just looking to see are there duplicate values within this primary key. Not a super efficient way to do it, but it's a way to get there. So we can define rules like this, or metrics like this, but we still need to understand what is the expectations on the behaviors. Am I allowed to have duplicates? Is it a no, absolutely no duplicates in this table? Or is it, yeah, we could probably have a couple, that's probably not gonna harm us too much? Or is it, okay, we get duplicates all the time, it's just, it's not really something that we need to measure. So we define that in an evaluation. And these are separate components, right? So the evaluation, you would pick an algorithm. You could say, I'm looking for something that's always equal to 0 or never equal to 0, or it should be within this range of values. In this example, we're looking at normal distribution, which is a fairly broadly useful algorithm for quality. And we are going to use that row count that we captured whenever the data was written, and we're going to look for a normal distribution of the data that we just wrote. And so in this example, we have a table that's loaded once a day, and we've defined an interval of 7. So we're going to go back 7 partitions, or 7 days in this case, and we're going to look for week over week because there are variances given the day of week on how many rows are written. And so we're going to look for week over 30 periods. So I'm going to go back 30 weeks. I'm going to say, okay, based on this week over week comparison of 30 weeks worth of data, the rows that I just wrote, does it fall within a 90% confidence interval? If it falls outside of that, I'm going to fail the job. So that's what this evaluation is allowing us to do. This is going to be really, really useful to identify those issues. But when you think about what it's doing, often just on its own, you would run this as a separate step after your workflow has ran. You're going to run it on your tables. You're going to find that issue, which is great, and you're very quickly going to notify people, wait a minute, that report that you just ran or your process just ran, and the data's bad, right? So good, but could be better. And so that's what we have WAP for. WAP is, it's unlike the first two, Metacat and Quinto, this is not a service. This is more of a pattern. And it's a pattern for ensuring that data is of a certain high quality before you make it available to consumers. But it stands for Write, Audit, Publish. That's what happens when you let engineers name things. So this is going to start with a production table that we want to write yesterday's data to using our WAP pattern. So we're going to walk through that. So this table has data loaded in it from the 1st of January through June 11th. We want to write data for the 12th. Before we do anything, kind of our first stage is this data prep stage, where we're going to create an identical copy of that production table. So we're going to pull in the same schema, the same SERDE, the same compression, and this is just an identical copy, but it's stored in a different database. It's going to be stored in an audit database. It's also the same table name, but it's going to have a timestamp appended to that suffix. And this is going to give us a single object to operate against for the entirety of this ETL execution. We are also going to point this to yesterday's data. So this is what I was talking about being really powerful. There is no concept of data movement or duplication here. We can physically point two different tables to the same physical data. And by doing that, when we go to do those evaluations and we want to be able to compare historic data, I can still operate entirely against this audit table. So it's really powerful. So once we have that audit table created, we are going to now run our ETL, and we're going to use a Spark job as an example. It could be Pig, and write into this audit table, and it's going to pass the data through to that S3 path and write it out to disk. This is the same physical location where the data will ultimately reside. We are not moving the data, but because tables are separated from our physical data, we've not notified our production table that this partition exists. So if I'm querying against my production table, I'm only going to see data up through the 11th. If I'm querying my audit table, I'm going to see data up through the 12th. If everything looks good, it will eventually see that partition. If it doesn't, that partition's just going to sit there until the janitor processes come and clean it up. And then also remember that whenever we write data, we are collecting those statistics. So at this point, we've also collected statistics in Metacat, and this is going to be a new object attached to the audit table, but it's a pretty fast process. So now we're ready to move to the next stage, which is audits. And we've previously defined in Quinto a handful of metrics and evaluations, so we can say, here's what the behavior should be, and here's what I want you to do to my job if you find something that fails. So we'll walk through the row counts, and we're saying the row count should be greater than or equal to 0. This is all going to be a little bit contrived, but there are many tables where that might be an expected behavior. So in this scenario, Quinta's going to read from the row counts from the Metacat partition object. It's going to see that it's 17,240. Yes, that's greater than 0. It's good. We're going to pass and move on to the next one. These are actually happening serially, or in parallel, by the way, but I'm walking through them serially. So the row counts are going to be the next thing, and now we want to compare the current value to the prior value. And so in a fact table, that might not really be relevant, but you can see this happening in a dimension table where you should always be having writing a greater number of rows. And so we're going to compare just our partition from yesterday to our partition today. We had 16,000, today we have 17,000. Yes, it's more than yesterday, we're going to pass. And then we're going to get to our null counts. And null counts, here we're going to say we're looking for a normal distribution because we had 21 before. And we do have nulls in this table, and we're really only trying to find out if there's a significant change in behavior. So we're going to look at the normal distribution. We're going to pull in 2 in this example, 30 in reality. We're going to pull in these 2, and we're going to say, okay, we went from 21 to 17,000. We probably have one field that's null across the board. That's a problem, right? That's going to fail. But we've defined our job to warn just so that we can continue with the example. So this is going to pass quality because it's going to warn instead of fail our job. And we are ready to move on to the next stage, which is publishing. So this is just a really quick operation. We now are going to see our production table again, and we are going to add that pointer to that physical table. So this is the point at which if I query against that table, I'm going to see that partition. This is the only point at which people would be able to see the data is after we verified that it's actually good. And this other audit table is going to go away. We are also going to update, we're going to do some other things in the publish phase around notifying downstream consumers that their processes are ready to run. We're going to update that valid through timestamp, but this is probably the most applicable for quality. All right, so now I am guessing that you guys, some of you are probably thinking, wow, that's really cool. I can totally see why that's a more efficient way to handle it at the scale that you guys are dealing with and how that would be really useful. And other people in here are probably thinking, oh my God, that sounds like so much work. I mean, I have to go understand the stats that are available in Metacat, which can change per table. I have to understand what the queries are that are available. I have to maybe write my own. And then I have to go set up the evaluations. And I have no idea, like, what's an appropriate level of coverage for this table because I just inherited it, right? Like, I don't know. And now I need to understand not only like what is the right level of coverage, but what are the expected behaviors? And that will take up a lot of time to do. And then that's not even touching the WAP stuff that we just talked about where I have to create these audit tables and change my jobs. It's a lot of work. And the reality is it is, right? So we have people that have gone through this process and they did this basically manually for our really large tables because they were really, really important. And it was a lot of work, but what we've done is built out a collection of Python libraries to make it a lot easier for users to be able to do this. So the first one is Jumpstarter. And this is really a helper library that makes it easier for users to configure and maintain their production data sets. And so this is going to do things like all those attributes I described earlier. It's going to populate them and make intelligent suggestions around that. But it's also going to help with the quality audits, right, and provisioning those. It's going to look at all of this rich data we have, and it's going to say, you know what, this is the type of table it is. It's a dimension table, and it's a snapshot of, every day I'm going to roll forward, like here's a new version of this table. So I'm going to check for behaviors compared to the prior version. I'm going to look for changes. And I'm going to do something different if it's a fact table. So I'm going to configure this. I'm also going to recommend what that right appropriate coverage is because I can see what the consumers are in the lineage. And then I can also have multiple tiers of coverage, so I can have a low, medium, and high. And then lastly, the rules are all configurable so that what we realize is things are not very similar across the board. So on the one end of the spectrum, you've got the product team with the streaming data, and they can pretty reliably expect certain consistent behavior over time. And so they can use a lot of normal distributions. The content team, on the other hand, doesn't have the same behaviors, right? They're dealing with a lot more like dimension tables, and it's coming from external sources. And so the quality challenges they're faced with and the ways to predict them are very different. And so rather than trying to come up with one solution, we said, okay, we're just gonna let you guys define your own rules. So they can define their own rules and run through this process, and it's pretty simple. So you're gonna import the dependencies, and then you're gonna define a jump starter table, and that table is just your production destination table. And you would run the generate audits function here. And it's gonna go through, do all this analysis. It's gonna come up with this list of recommendations. You could edit that list, or you could just pass it directly to Quinto, and it's gonna provision them. So this model makes it really, really easy for people to set up the audits. But it also lets us do something different, which is that, you know, when you think about the life cycle of a table, as it's moving through its stages, and as the audience of it is changing, really the types of audits that you should have on it should also change. And that becomes really difficult to manage when you've got tens of thousands of tables. So instead we can say, okay, we're gonna identify when one of those conditions changes, and we're just gonna run this automatically, right? We're just gonna do it for you if you opt into that sort of model. So it gives us a lot of ability and capabilities around just being able to manage the audits that we would define inside of Quinto. We also built a library for WAP, which we call WAP because we suck at naming things. And the concept here is to make it super easy to use. So if you have a production table and it's loading data today with some sort of ETL job, Pig or Spark, there's only one change that you have to make to use it, and that's that you parameterize the destination table. There's no other changes, right? And then once you do that, you can run WAP. So it was intentional that we made it as easy as possible for people so they could opt in to converting their tables to this. And then actually running WAP, we are importing our dependencies again. So this time we have Craggle and DA Core. DA Core is our Python library, and then we have these modules underneath. And so you'll see here that we're defining via Craggle a Genie job, and it's a pointer to that physical file that we just looked at, the one where we changed the database in the table. And so we're defining, here's my job, here's the table that I'm gonna operate against, my WAP destination table, and I'm gonna execute. I'm gonna execute the job, and it's gonna load into that table. Super, super easy. Now behind the scenes, it's going through all that other stuff. It's gonna go create the audit tables. It's gonna go check to see what is the number of partitions that I need to pull in because of the rules that you've defined. It's going to actually pass that new audit table as a parameter to the job. It's going to it's going to collect any metrics that need to be collected. It's then going to run the evaluations. It's going to make some decisions around, do I need to fail my job or not? And if everything looks good, then it's going to publish, right? And so you can call those individually as part of this, but if you're on the paid path and everything is good, super simple. Okay, so what I've described here are 4 different components to our data quality solution. And I think it's pretty important to consider these all together, because when we're talking about scaling data quality, we really have 2 different ways to look at this. The first one is the process, right? We need something that's going to scale to support the billions of rows that we're writing, and it's going to do it in a pretty efficient way. We also need to scale the management of that, because it requires a lot of work to manage data quality, right? And so we need something that's going to be super simple and a low level of effort in order to implement it on those tens of thousands of tables. And so it's really this all together that allows us to scale data quality. So we could provision 108 audits. So I ran through a test, and we have a table that has about 200 million rows that get written every hour. We provisioned 108 audits and changed our ETL script to be parameterized. Took about 5 minutes to do all of that. And then we actually executed the evaluations as part of the job, and I think it added 42 seconds to the entire runtime. So super efficient when you think about the amount of effort required for your data engineers. Okay, so we've got this out there, and we're using it for new development. There's still more things we want to do. We want to expand the stats that we're collecting with Metacat, so we want to add histograms and approximate cardinality so we can do more stuff more efficiently, and also share that out with the Spark rules-based optimizer. We also, our cloud platform team has built a anomaly detection service, and we want to integrate with that so that we have better capabilities around like asymmetric data distributions or seasonality, like worldwide seasonality, which might be more difficult for us to understand. And then we also want to complete the migration of all of the production tables we have. So we haven't completed that yet because you do have to go touch the job and touch the schedule. So we'll be completing that probably in early 2018. Now, the takeaway for you guys is, the principles that we've discussed, but also, I don't want you to run back and say, okay, we have to be doing all this stuff. If you start with a query-based solution, that might be good enough for a lot of people's needs. If the data's small enough, if you're running it once a day, it's not super efficient, but that's okay, or it might be okay for you. If you have large volumes, then forget that, collect stats. The other thing is a lot of companies say, okay, we're going to do data quality. This is going to become important, and everybody has to do it. And that is absolutely the wrong model to take with this, right? Because not all tables need quality. I mean, you might have ones that are transient, ones that are experiments, ones that might never get out of proof of concept stage. It might have a single user. And really, when you force them to have quality, you're slowing down your team and your environment, and it's not worth it. The other thing is that data quality, as I mentioned, is really, really hard. And part of the reason why it's hard is because you have so many different behaviors across different types of teams. So what we would expect for marketing probably is not going to work for finance, and it's probably not going to work for streaming. So try to avoid building a one-size-fits-all solution, and instead really try to go after that core 80% or even 90%, which is what we've tried to do, and say, okay, whenever there's stuff that falls outside of that, you can go build your own, but really start with that core 80, 90%. And then the last thing, and I think this is super, super important, is data quality is something that is going to vary dramatically. And if you build a framework for it, then people are either on the rails or they're off the rails. And if they're off the rails, then they're completely off the rails. And you don't want to do that. So if you think about not building frameworks, but instead of think about building components, then when somebody's on the path and they find that something doesn't work, they can take a detour, but then they can come back, right? And they can call these components individually. And so that is a much better way to develop than it is to use frameworks. It also allows for greater flexibility and capabilities of your solution, so I highly recommend it. So that is my talk. I know you guys are all hungry, so I'm not going to keep you, so feel free to leave, and I will stick around for questions. Thank you.